In this video, we're going to take a look at the final section of the Common React Pitfalls category on the Veracode Security Labs Community Edition, and the lab's called Dangerously Set HTML Links. The description says React's dangerously set inner HTML and markdown rendering craft a malicious href. So let's start the lab. So the first section is called Reconnaissance, and it gives us a little bit of a recap on the previous lab where we used the JavaScript pseudo protocol to inject a alert pop-up box. And like the previous example we looked at, this vulnerability is not unique to React. It's just a common mistake that you'll see on React-based web applications, and that is the dangerously set inner HTML, which is React's method for setting inner HTML. It's called dangerously set inner HTML because it's easy to introduce cross-site scripting vulnerabilities when dangerously setting the input. So Veracode found in their research that vulnerabilities resulting from this method are still very common, and we're going to go through one way that they can be introduced in this example. So to complete this step, when the link appears, we're able to go next. So we have this page here, the memereview.com. Let's open that in a new tab, because I want to just get this out of the way so we've got more space for the terminal and the code editor. So it says that this app uses Markdown for the review content, specifically a library called Marked. Can you spot the XSS vulnerability? And we're asked to write a new review. Inside of the review portion, try adding a sneaky link that includes JavaScript. Remember the use of the JavaScript protocol from the previous lab. So let's go first of all, try and create a new review. Let's just put in JavaScript and just do a standard alert and see what happens. I'm going to put this in these as well, just in case, and we don't get anything. You can see that it's stripped out our JavaScript there as well. Let's actually just go in quickly, do this with the capitals as well. We could just go and review the source code and see whether this is actually going to work, but let's do some black box testing in this case and just pretend at the moment we don't have access to the source code. Alright, so okay, so yeah, with the capitals that did actually allow us to complete the XSS as well. And now we can go on to the next section. So now we're being asked to think back to the server-side rendering to our first lab where we injected the JSON. We injected into JSON closed off the script tag and injected a script. So that was basically stored XSS. In this case, this URI XSS vector is slightly less dangerous because the victim has to click a link for the payload to run. So it's not just going to be stored on the page. We have to deliver them a URL through some kind of phishing technique or social engineering to actually convince them or trick them into accessing the link. So let's see if we can inject these markdown pages in the same way as we did with the SSR. So make a review that contains this script. Okay, we'll do that. Let's paste that in here. Paste it into the link bit as well. And we have a link. It's kept the script in there. So let's try and open that. Kept the script in there, but it didn't actually note that it didn't actually print the script. We're not getting a very nice format here. Let's see if we can HTML beautify, codebeautify.org. So just a quick way, if you can just throw it into VS Code or Codium or something as well if you have auto format on, but a quick way just to, if you want to have a look at the source code, if it's all been put on one line like that. Okay, I don't see any sign of our script in there. So let's go back and have a look. Oh, it actually let us go on to the next page though. So we made a review, but it didn't actually. So we're told here that adding the script using set inner HTML doesn't work even for benign purposes. That's because it's being added as a DOM node and not evaluated since the page is already loaded. However, there is a trick to successfully running an injection on a payload on page load with set inner HTML. Can you figure it out? So instead of adding a new review for each test, feel free to use the XSS tester feature on the app's homepage that works in the same way. Okay, is that? XSS tester. I don't see that feature. Okay, to complete this step, we need to inject a review such that the JavaScript code runs when the page loads. The link has some helpful details, so this link here, presumably. And if you do manage to make an alert pop up but can't proceed, let us know. This means you've discovered a new vulnerability that even we didn't expect. Okay, so let's have a look at this. Can scripts be inserted within a HTML? I tried to load some scripts into a page using inner HTML on a div. It appears that the script loads into the DOM, but it never gets executed. Is there a way to have scripts execute when inserting them? So somebody suggests you can use eval to execute any script code that you've inserted as DOM text. Somebody else also suggests that you can, instead of using script tags, you could use this image source. So this is quite common on general XSS as well, as using image source, and you can have as well so you could have an image source set to an invalid image and then say on error do some kind of malicious execute some code or just pop an alert or something like that. And then if the source is invalid, it's always gonna launch that error and execute the code. So there's a few different solutions on here. Let's let's try the image on load error. I'll take a copy of this and let's go to our React app, new review, and then in the link here we'll say image source, and I'll just put in here test. It's not going to find test, so on error we want to try and create this alert, and then we want to just close this off. So we'll close off the tag, take a copy of that, I'll put that in there as well. Let's run that, and there we get our alert. Okay, so we get our alert, and now we're able to proceed to the next stage. So finally we get to the patch. And it says here marked, the markdown library that we're using, which we didn't even really go and check the code, but here you can see that they've highlighted here with the red. They seem to highlight the important code to go and check out. So you can see that they imported this marked from marked, and they were using that to create the markup. So you can see here, create markup. So it doesn't run full sanitization on the output for a good reason. It's complicated and there are a lot of different opinions on how to do it. A library that specializes in just sanitation is a better choice for escaping dangerous strings. So Marked recommends DOM Purify, so there is a module for this, which is receiving active development and is frequently relied on in the wider community. So I think you'll get from the previous labs the general theme of these vulnerabilities and the general fixes involve using tried and tested libraries which have open source where possible, so they've got as many eyes on identifying bugs as possible. It says here, important sanitizing should be done after the markdown rendering happens, otherwise attackers might come up with tricks to fool the markdown engine after DOM Purify has done its job. Plus the wrong combination could result in rendering issues and a bad user experience. So we're being told to install this. We'll take a copy of that and paste it into the terminal. And when we install that, note that the version of Marked is in fact has a specific sanitization bypass vulnerabilities reported. Okay, so it's going to let us know that there are some vulnerabilities with the Marked library that were being used. So to fix this, we're going to go and import this. Let's okay, found a lot of vulnerabilities there. Okay, let's go and import this then. So we'll go to review.js, and at the top we're going to import DOM Purify. And in the create markup, which is right here, we're going to wrap this, the marked render function, with a new sanitizer. Okay, so rather than just returning the HTML using the marked, let's go and paste this below it so we can see the difference. It's calling DOM Purify, the sanitize function within this library, and it's passing the same parameter, the same result in there. So we want to run npm build. Let me save this first of all, and npm run build. Just while that's running, let me note as well, again, I think I mentioned this in one of the previous videos, but in the link in the description I'll put some links to some good articles about these types of vulnerabilities, and this one particularly covers the 3 security pitfalls. So everything that we've been through, the 3 different vulnerabilities, are explained quite well here, with some good examples. So if we go down, this is the lab that we're going through at the moment, misunderstanding what it means to dangerously set, and looking at this dangerously set in a HTML, and it goes through some examples in there from real world examples. Alright, so there we go, we've built that. Let's go and test the app with a new review then. So we'll go back here, new review, and I'll do the image source equals test, and then we'll say on error we want to do an alert, and let's close that off. I think hopefully that's the right syntax for that. Let's create the post. We have our link, and if you see down at the bottom there, it has our image source test, and then on error it's going to try and run that alert, and it doesn't pop up with the alert. Was that? Just make sure I had that all in right. Yeah, it looks like it. The only thing I didn't put in a semicolon there, but that shouldn't really matter. Let me just double check just in case. So we'll put in a semicolon. I'll put that in here as well. It's a good idea to check each of the the form inputs here, so that the developers might not have validated all of them. So actually in that case, yeah, it did actually produce the alert still. I'm actually not sure if that was intended, or maybe in building this I didn't deploy something properly. Save, run. We could go back and do okay, app is running. Is it the same place it's running at? Let's just quickly do one more quick new review. We just do it in the link bit. Oh, it's not actually letting me submit that. So let me try that again. View all reviews, new review, paste that in there, paste it in there. Okay. Okay, so now it seems to be preventing us from even submitting that. Let me see if maybe just the system's broken. It's not letting me submit anything. Yeah, it's just not letting me submit anything. All right, I think there might be some issues with the lab there, but we've done everything it asked us to, so the lab's complete. And let's just see what the last tips are. So there are a million ways using dangerously set in a HTML that can go wrong, and one of the more common ways is with Markdown. So basically you always want to make sure input is being sanitized, and when inserting user input as in a HTML, the best way to know whether the input is vulnerable is to penetration test it. So you can get here's a list of some good payloads to try. You can also build up some good XSS payloads from the Web Security Academy. Let me go to that quickly. In fact, I'll search XSS cheat sheet. Spelled cheat wrong, but I'm sure Google will help me out. So you can go in here and you can actually find things specifically based on the browser and stuff as well. So in our example, if we know, for example, that a href is going to be blocked, we can say, right, well, we're going to try and use figures then, and then we'll select the figure, and then there are different events that we can select here, or we can go through and just find event handlers that don't require any user interaction, and then you can have a look and see what browsers are they going to work on, or are they likely to work on, and then you can just copy this code to go and test it out. You have other ones that will require user interaction, so it requires you to copy a piece of text in order for the script to be executed, etc. So yeah, those are some things worth checking out. And it's also a good idea to have a linter warning, so whenever you're compiling code, have something that warns you that you have function calls to dangerously set in HTML and eval, and then it'll be harder for developers and testers not to actually ship things out, to deploy systems with these dangerous calls in them. Rather than dangerously set, you also may want to consider specialized packages such as HTML React Parser as an alternative solution. Okay, and that wraps up the common React pitfalls. So next we'll take a look at the OWASP Juice Shop.